We will work out one problem uh, that is find the adjoint of the matrix A equal to 1, 2, 3, minus 5. So you know that this is a 2 by 2 matrix. But there is one more question added to this. Verify A into adjoint of A is equal to adjoint of A into A equal to magnitude of the determinant A into I. Here it becomes I2 because the given matrix is a 2 by 2 matrix. If it is a 3 by 3 matrix, you have to write this as I3. It is an identity matrix which is also called as unit matrix. Okay, so this is the question. Now how to solve? First we have to solve the first part. First part, what to do? How to solve this? So given equation is of the form the general form which we already written earlier. You know that A11, A12, A21, A22. Okay, this is the general form. So now how to write its cofactor matrix? Cofactor matrix. Why we want cofactor matrix? In order to find the adjoint, we have to take the transpose of the cofactor matrix. So cofactor matrix, how do we write? We use the capital symbols to write the cofactors. So that is A11, A12, A21, A22. So now we have to find each of the cofactor, and we have the formula to find the cofactor. What is it? Aij is equal to minus 1 to the power I plus j into minor of Aij. So there are only 4 cofactors. So let us write it here itself. So there are only 4 cofactors. So what are the cofactors? First one is A11. So A11 is minus 1 to the power 1 plus 1 into, what is the minor of 1? A11, its corresponding value there is 1. So its minor is other than that element containing one row and that column you avoid. So what is remaining there is minus 5. This is the minor there. So when you solve this, you get this as minus 1 to the power 2 into minus 5. Minus 1 to the power any even number is always plus 1. So you get here that plus 1 into minus 5 as minus 5. This is A11. So in the same way, how to find A12? So A12, let me write here, A12 minus 1 to the power 1 plus 2 into the minor of A12. What is minor of A12? So you have to eliminate the row containing 2 and also the column containing 2. So what is remaining there is only 3. So 3 is the minor there. So this becomes minus 1 to the power 3 into 3. So minus 1 to the power 3 is minus 1. So you get this as minus 3. So the third cofactor, that is A21. So A21 is equal to minus 1 to the power 2 plus 1 into the minor of 3. Minor of 3 is what? It's only 2 there. So you get this as minus 1 to the power 3 into 2, that is minus 1 to the power odd number, that is 3 is odd there, so minus 1 into 2 is minus 2. Then the last one, that is the last cofactor A22. A22 is minus 1 to the power 2 plus 2 into the minor of minus 5 is 1. So you get this as minus 1 to the power 4 is 1 only into 1. So you get this as 1. Therefore, the cofactor matrix, cofactor matrix is minus 5, minus 2, minus 3 and 1. Okay, this is the cofactor matrix. But what we want is adjoint of a matrix, right? So how to find adjoint of matrix? So adjoint of a matrix A is equal to transpose of cofactor matrix. So just take the transpose of the above cofactor matrix, you get adjoint of A, that is minus 5, minus 3, minus 2, 1. So this is the adjoint of A. Now we are asked one more. What is that? A into adjoint of A is equal to adjoint of A into A, that is equal to determinant A into I2. So now what we do is, first let us find out A into adjoint of A. A is the given matrix. So what is a given matrix? Given matrix is 1, 2, 3, minus 5. Into adjoint, just now we found the adjoint of A, that is minus 5, minus 3, minus 2, 1. So you have to multiply. Multiplication you are familiar. So how to do that? This is a 2 by 2 matrix. This is also a 2 by 2 matrix. So what you get, the result is also a 2 by 2 matrix. That is 1 into minus 5 plus 2 into minus 3. You know multiplication, right? So 3 into minus 5 plus minus 5 into minus 3. Same way, the next column, that is 1 into minus 2 plus 2 into 1, then 3 into minus 2 plus minus 5 into 1. So when you solve this, you will get minus 11, 0, 0, minus 11. You call this as equation 1. So now you find out adjoint of A into A. So what is it? Just to reverse it, that's all. So minus 5, minus 2 into minus 3, 1. This into A. What is A? 1, 2, 3, minus 5. Okay. So now you have to multiply this just like the previous case. So what you get is minus 5 into 1 plus minus 2 into 3. Similarly, minus 3 into 1 plus 1 into 3. The second column, minus 5 into 2 plus minus 2 into minus 5. Similarly, minus 3 into 2 plus 1 into minus 5. So when you solve this, you will get minus 11, 0, 0, minus 11. You call this as equation 2. So next we want to find out determinant A. So how to find the determinant of A? Determinant, now you have the given equation as A, right? That is 1, 2, 3, minus 5. So how to find its value? 1 into minus 5 minus 3 into 2. That is minus 5 minus 6, that is equal to minus 11. Now what we want is, we want to find magnitude of A into I2, that is minus 11 into I2 is a unit matrix of order 2 by 2, that is 1, 0, 0, 1. So this will be, when you multiply minus 11 to the unit matrix, you will get this as minus 11, 0, 0, minus 11. Okay, this is equation 3. Now just compare the equations. We can find out the given theorem is verified, that is from 1, 2 and 3, what we can conclude? A into adjoint of A is equal to adjoint of A into A, that is equal to determinant A into I2. So hence the theorem is verified. Okay, so this completes the problem. See you in my next video.